Okay, this is the video on graphing systems of equations and the different types of solutions we can have. So at first I want you to just copy these statements down. We'll be using those in class. So a system of linear equations is two or more linear equations that use the same variables, and the solution to a system of linear equations is the point that makes all of the equations in the system true. So go ahead and pause if you want to copy that down. Okay, so if you're done copying that down, one way that we can solve a system of linear equations is by graphing them. So we're looking for the point of intersection. We're looking for the point of intersection, the place where the two lines meet. That's the solution. So let's graph these two lines. So we're going to graph y equals 4x plus 4. It has a slope of 4, or 4 over 1, and it has a y-intercept of 4. So let's graph it. So there's the y-intercept of 4, and the slope goes up 4, right 1. We don't have space, so we'll do it in reverse. So we'll go down 4, back 1. And we'll do it again, down 4, back 1. So this is our first line. So remember, every point on this line is a solution to that line. What we're looking for is a solution to the system, meaning the two equations together are a system. So we're looking for the point where the two lines will cross each other. So now we graph the second line. So this one has a slope of 1, right? That invisible 1 there. So we'll think of it as 1 over 1. So that's 1 up and 1 to the right, and a y-intercept of -2. So go to -2, and let's go up 1, right 1, up 1, right 1, up 1, right 1, up 1, right 1, and we can see that it's going to cross somewhere back here. So this point right here is our solution. Okay, so this point is the solution, right? It's the point that makes both of them true. So let's do another example. So here we have the equation y equals -2x plus 3. We have a slope of -2 over 1 and a y-intercept of 3, or 0, 3 we should say. And here we have this line has a slope of 3, or 3 over 1, and this y-intercept is 0, 2. So we're going to graph both these lines, and we're looking for the point where they cross. Their point of intersection is the solution. So this line crosses at y equals 3 and goes down to right 1, down to right 1, down to right 1. So all of these points are solutions to this line, but only one of them is a solution for the system, meaning for both equations. So now we'll graph the second line. It has a y-intercept of -2 and a slope of 3. So it goes up 3, right 1, up 3, right 1. So there's our solution, that point where they cross. So we can see that so this point is our solution. This is the solution to the system of equations, meaning the two equations, the solution to both. So this is the point 1, 1. So what that means is x of 1 and y of 1 makes both equations true. So let's check the solution. So that means that we could plug it into our first equation and then plug it into our second equation, and both would be true. So let's try that. So let's plug in a 1 for y, it's coming from there, and a 1 for x, so that's negative 2 times 1, plus 3. Negative 2 times 1 is negative 2, plus 3. Negative 2 plus 3, different signs subtract. Keep the sign of the bigger number, so that's going to be positive 1 equals positive 1. So this is a solution to y equals negative 2x plus 3. Now let's check if it's a solution for this one. So we plug in y equals 1. We plug in x equals 1. 3 times 1 is 3. 3 minus 2. 3 minus 2 is 1. So it's true, 1, 1 is true for both equations. So this is the solution to not just this equation and this equation, but the solution to the whole system, meaning both these equations together. And we can see that if we graph them together, the point of intersection, right? That's the point they cross, the point 1, 1. So our solution, we see it on our graph as the point of intersection, and we see that that solution works in both equations. So that's how you solve a system of equations by graphing. So remember that a system of equations is when you have two or more equations that are using the same variables, and the solution is the point where they cross. So if you graph them, the point where they intersect is their solution.